Good morning, everyone. Today, we as a group will be presenting our Capston project work based on the title Implementation of Solar Irrigation System with Humidity Sensor in Biogardens of Public Educational Institutions. The group is confirmed by the following members in screen. And next one, please.
Implementation of a solar irrigation system with humidity. According to the Food and Agriculture Organizations of the United Nations, it explains the relevance of biogardens by height, their contribution to food security, nutrition, and sustainable development. The United Nations (ONU) reaffirms to us that growing space are of hummus analysis and not only allow access to fresh and healthy food, but also promote sustainable agriculture practice and strengthen the resilience of communities in the face of climate and economic change. By fostering biodiversity and reducing dependence on external inputs. Biogardens are a key tool for improving the quality of life and well-being of vulnerable populations. This is why the, the informs us that it's vital to have biogardens in order to aim for a sustainable future while the ODS in the international education framework.
At this point, according to the ONU, biogardens are super important nowadays, and the public schools of Lima, Peru have implemented biogardens as part of their educational curriculum. However, these biogardens are often in poor conditions, with dry soil and no vegetables, as you can see in the image, due to limited investment in infrastructure and the lack of an adequate irrigation system. The main problem is particularly acute in schools in the poorest areas of Lima, where the lack of resources and water make the maintenance of biogardens a constant challenge. This situation not only affects the ability of these schools to provide an effective environmental education, but also limits their contribution to the food security of their communities. Therefore, there is an urgent need to develop innovative and cost-effective solutions to improve the condition and efficiency of biogardens in public schools in Lima. We'll continue with the formulation of the causes from this particular problem. Next one, please.
Mm. Thanks to analysis behind the Ishikawa diagram, we were able to identify the problem that the biogarden in the public schools are not operating efficiently. We will examine the various possible causes of the problem. First causes labor, lack of staff training, person demotivation, and staff turnover. Other cause is measurement, inadequate monitoring of staff, lack of achievements according the hater condition, and lack of monitoring technology. Other cause is materials use of inappropriate fertilizers. There are no bats to work on without damaging the organic garden and lack of mulch and ground cover. Other cause and machines insufficient number of equipment, lack of maintenance, and obsolete equipment. Environment, there is no organic source of certain compost, so the climate change and lack of ventilation cover. We consider that the method has the greatest impact and the use stems from the improved use of irrigation. Incorrect irrigation techniques can result in water wastage and either excess or insufficient water of the growth of the vegetable. Therefore, our project aims to present a new irrigation system that is accessible, efficient, and is easy to implement with the objectives of revitalizing the biogardens and maximizing the impact of the school communities in Lima. The system will include a moisture sensor to control the water level in the soil, thereby promoting greater sustainable crop growth. Next, please.
Here we have designed a prototype. For that, we have used the Fusion program. Then the second part will be to print it in 3D. The cylinder that you see in the middle will be filled with water and is connected to a humidity sensor. The light that you can see here will serve to open, so the water can come out as drop and it will collide with the dome, and the dome will spread on the sides and it will close when the humidity reaches 15%. The part below that can be seen will be used to put the battery. We will put this prototype that we have designed underground. Next, please. Next, please. Next.
So the logic behind it is that when there's too much hot in the weather, the the water will evaporate, and and the water will be put in the top of the dome. Then eventually it will fall and making the dry soil more humid, and with that we can make the plants function better. Next one. And conclusions.
Conclusions. Our prototype will be help improve biogardens, science students will be more committed to caring for them. Also, complying with ecological standards, science it will not generate as much plastic as other cheaper irrigation systems. Thank you.
Thank you.
Ya, lo voy a finalizar, lo bajo y lo subo al grupo, ¿ya?
¿Cuánto
Sí,
hay?
sí.
¿Cuánto duró, Carlos?
Hay 8 minutos y medio.
Ah, a
Casi
nada.
9.
Ya, lo voy a este. No me toques.
Ay, 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 yo te-